Hello everyone, my name is Stanislav, and in this video I want to tell you about my new project, an electric rocket. Let's go! To begin with, I will tell you the background. A month ago I wanted to make a Starship rocket in a small copy. I decided to use the motor as rocket engines and the Arduino as a computer. I really liked this idea and I decided to implement it. Let me tell you about the characteristics of the rocket. On the board, the rocket will be 2 motors, 2 controllers, 2 servos, a parachute, an Arduino, a memory card module, as well as temperature, pressure sensors, a gyroscope. With the help of these sensors, Arduino will control the flight, speed, and altitude of the flight, and turn the rocket in the right direction. Also, all information will be recorded on the memory card for further research and improvement of the rocket. We will talk about how the rocket will turn in the right direction a little later. And now we will move on the main characteristics. Based on the fact that the rocket will be 50 times smaller than the Starship rocket that you can see now on the screen, the height of the rocket will be 100 centimeters and diameter 18 centimeters. But the most important thing is the speed, time, and altitude of the rocket flight. To calculate this, you must first pick up the motor and propeller. I choose this engine with 2006 RPM and a free-bladed 4x4 propeller. The first 4 means the length of the screw in inches, the second the length of the pitch of the screw in inches. We can find out the speed. For this we find out how many revolutions the motor makes per second and multiply by the pitch length of the screw. We get 4.37 meters per second. To find out the altitude of flight, we need speed and time. We have speed, but there is no time. Therefore, we need to calculate the battery discharge time. Let's take a 2000 mAh battery with 11.1 volts. That means 3S battery. 2 motors with controllers for 30 amperes. Each will be installed on the rocket, which means the battery amperage will be 60 amperes. 2000 milliamperes per hour is 2 amperes per hour. 2 amperes per hour divided by 6 amperes and multiply by 60 to get the answers in minutes. We get the 2 minutes. Multiply the time by the speed and get the distance of 524 meters. Of course, 524 meters is not an exact height, since I calculated without the weight of the rocket, gravity, air resistance. Since it is impossible to launch airplanes, quadricopters in the country in which I live over 120 meters, because radars work over 120 meters. Therefore, we will launch the rocket to a height of 100, so that there is a margin of 20 meters. An important parameter is the weight of the rocket and the thrust of the rocket. The weight of my rocket will be 800 grams, and the thrust of the engines should be 1 kilogram, 600 grams, which is twice the weight. Now we know all the characteristics of the rocket, but how do we safely land the rocket? A parachute will be installed on the nose of the rocket. When the rocket flies down, the cap of the rocket will open with the help of the small wings, and the parachute will get out of the rocket. In addition to the parachute, motors will be turned on the further reduce the speed. I made an animation that shows the work of the servos that will turn the motor so that the rocket flies smoothly and the wind does not interfere with the flight. This project will be very difficult and expensive. If you want to help in its development, you can donate any amount using the link in the video description. I will be very pleased. We have reviewed with you all important parameters of the rocket. In the following videos, I will tell you in detail about the rocket news, about every moment of the flight. I will tell you the options for opening the parachute, ways to save the rocket in cases of engine failure or rocket flip, and much more. Subscribe to this channel so as not to miss interesting rocket news, and I will see you in next videos.